Welcome to a video where we're going to explain the station number 1, 2, 3, and 4 from physics. Let's get started.
My name is Marco Garcia and I'm going to explain you the stage 1 of physics that is about fluids. There are many topics in this stage, so we are going to summarize the topics to see all of them, and I hope you understand all the explanation. Well, we begin with the states of matter. We know that are only 4. We see it in the first levels of chemistry. Well, the states of matter are solid, liquid, gas, and plasma. Yes, that are the states, and they have characteristics that we are going to see. The first one is the solid. The solid we relate it to the ice because it's the easiest way to remember it. We see it in the elementary school that the ice is the water freeze and it comes a block. Yes, and it's solid, like the word solid. That means that the particles don't have much movement, but they can move a little bit, just a little bit, and they are pretty closer one of them to another. That's the most general characteristic of the solid that we recognize. So we pass to the liquids. The liquids are water, simple as that. Like drinkable water, and we see it in a river or in the ocean or that stuff. Yes. Well, they are capable to flow. That's what we have pipes, and we turn off the key of the pipe, and we have water and air. The molecules in this state we know that are kind of distance one of them to another, and they are in movement, not like the solid. And the liquid can have the shape of the container that we put them. If we put it in a beaker, the water will have the shape of the beaker. Okay, then we have the gas. Yes, the gases are compressed easily and take all the space of this container, of its container. That's where we have the containers of oxygen to go to the space and can breathe, because in the space we all know that there is no oxygen, and we can put liters of oxygen in them, so we're going to have to survive. The molecules in this state are in constant movement and move very fast, one of them, and we can't know what distance of a molecule of oxygen have to another molecule of oxygen. They are, like I already say, in movement, in constant movement. And the final one is plasma. It's a gas like the past one, but the atoms are ionized. This means that some atoms have been separated, or all the electrons, converting it in a mixture electrolyte neutral. So that means that it isn't negative or positive, it's just neutral. Yes, we recognize the plasma like the thing that is very hot as much as the surface of the sun. And that's it. That's all states of matter. Pretty interesting, but it's easy to remember it. So we need to pass to another topic, that is density. Density, more specifically or more precisely, the volumetric mass density. That is the mass of a substance per unit of volume. That's why in the formula that we see in this image is kind of P equal to M per V. It's a division, like the sentence I said before. It's a Greek letter, the thing that we put before the equal, the A, and it means obviously density. The units that we have in the international system are kilograms per meters cubic, but frequently it is used the units of the system CGS. Which are they? Well, they are the grams per centimeters cubics. Also, we are going to see the equivalence. Well, not the equivalence, just the units, right? They are in the image, and not much to say that at this topic, but it's related to the specific weight and the relative density. Because the density of a substance can be also expressed on a relative scale called specific gravity. That's why the specific gravity enters in this topic. For the fluids and solids, the relative density is defined as the ratio of the density of a substance to the density of a given reference material. In the formula, we see that we compare the density between water, and that gives us an equal, that is the specific gravity, and this is the density of an object. But we need to have more data to complete them, so that is in very specific cases. Then we have the concept of pressure. Pressure, we know it as the amount of force applied perpendicular to a surface of an object per unit area. Yes, the pressure is a scalar quantity, and we see a diagram that describes us the sentence I already said, and also the formula to give us an idea that we are talking about. We pass to the press and the fluids. The direction, we see the image or a draw that the direction of the fluid when flows out is perpendicular to the walls of the container. So it means that the water or the liquid exerts the same pressure in all directions. And to obtain the pressure, we have this formula and this kind of diagram or images to know it. That's what we have, different pipes connected to the bigger one to pass the water to other sites, and it also can go stronger than to pass only for the bigger one. We can, that's why we have pipe, different kind of pipes in our house, and we have water in the restroom, in the bathroom, in the kitchen, or different places, right? Okay, then we have the atmospheric pressure. Yes, that one that no one see in the notice and in the news. Sorry, in the news. It's atmospheric pressure. Sometimes also called barometric pressure. Is the pressure within the atmosphere of the air. In most circumstances, atmospheric pressure is closely approximated by the hydrostatic pressure, the weight of the air above the measurement point. Okay, we know that atmospheric pressure, and it have mechanisms. The mechanism is the atmospheric pressure is caused by a gravitational attraction of the planet on the atmospheric gases above the surface, and is function of the mass of the planet, the radius of the surface, and the amount of gas that is vertical distribution in the atmosphere. It is modified by planetary rotation and local effects such as wind velocity, density variations due to temperature and variation in composition. Okay, that's all we know about atmospheric pressure. It's kind of confused, but we know it. We also illustrated by the images that I put in the video. Then we have the final one, I guess, the final topic of this stage. No, we have another topic after that. Okay, we have the Pascal principle. Yes, the Pascal principle. We know René Pascal, but in this case, it helps us to physics, not mathematics. Well, it says that it's a pressure in fluid mechanics that states the pressure that a change occurring anywhere is confined incomprehensible fluid is transmitted throughout the fluid, such as the same change occur everywhere. Okay, I put images to understand it because it's kind of confused. The explanation, the concept, and also I put the formula, that is the difference, or delta P, that is pressure, equals the density, the gravity, the difference of the height. But in the book says that it's only the height, no different height. Okay, the last one that we have in the stage 1 to pass to the examples in real life is the Archimedes principle. Yes, this one is also kind of confused when we talk about it just for 30 seconds, but that's why I put images to understand it much better. Well, it states that the upwards buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of the mass of displaced fluid. Okay. Kind of understand, but I put obviously the diagram, and you can put it on test by grabbing I don't know, little balls or a stone in the water, and don't let it go to the don't let it go down, and we put it to the test, and that's it. We can see it in action. Yes, and that's it. That's what we have in this stage, and we see it obviously all the diagrams, not only the one that I explained, and yes, are very interesting and kind of useful, but much interest. I'm gonna talk about the examples in real life that are in the distribution of water in the houses. They put pressure to the water to go like, I don't know, like kind of explosion, because the liquid is can exert the same pressure by all the ways that it can be in a pipe or stuff like that. Like I already said, in a balloon that is perpendicular to the wall of the balloon, so it's perpendicular to the surface of the, well, not the surface, the in of the pipe, and that's why all the houses we have water. Yes. So the other distribution is distribution of gas, and it need to have pressure. Yes, like liquids burn much less because the gas is easily compressed. The gas that we have in our house is the gas that we have in the kitchen, that is the methane gas. Yes, we have it in the service of gas natural, and in the pipes of the gas are very smaller. Yes, smaller than the pipes of the water, because like I already said, the gas can flow and occupies all the volume of the pipe and flow easily to our houses. And I think that's it for this video.
Stage 2. Heat. In this stage, we saw how heat is different from temperature. Heat is the transfer of kinetic energy from one medium or object to another, or from an energy source to a medium or an object. Such energy transfer can occur in three ways: radiation, conduction, and convection. On the other hand, temperature is the degree or intensity of heat presented in the substance or object, especially as expressed according to a comparative scale, and shown by a thermometer or perceived by touch. We saw how to transfer heat from another object. It is called thermal equilibrium. When a higher temperature object is in contact with a lower temperature, will transfer heat to a lower temperature object. The object that was transferred heat will approach the same temperature and they will maintain the constant temperature. The kinetic molecular theory of matter is a concept that basically states that atoms and molecules possess energy of motion, kinetic energy, that will perceive as temperature. In other words, atoms and molecules are constantly in motion, and we measure the energy of these movements as the temperature of the substance. This means if there is an increase in temperature, the atoms and molecules will gain more energy, kinetic energy, and move faster. A way to use this in a normal day is by knowing the temperature at the moment and what the weather of the forecast is for today, since it depends on the kind of clothes we will select to leave our house. Heat sources in homes, industries, and companies. The most commonly used heat sources are boilers, and efficiency exceeds 80%, the most efficient being those that heat recover. Also, the centralization of the generation for the whole building contributes to the efficiency. Environmental cooling in buildings and institutions. Refrigeration is necessary for everyday life. We depend it for food preservation and air-conditioned spaces. Industrial processes that require reducing temperature of machinery or materials for its proper development. Some examples are machining, plastic manufacturing, and nuclear power production. Thermal exchange devices. As said earlier, there are various ways to transfer heat. Some of the methods are direct contract exchanges, are those in which the heat exchange is made by physical mixing of the fluids. Indirect contact exchangers. There are those in which fluids do not come in direct contact, do not mix, but are separated by the solid wall, a space, or even a time. Reciprocating heat exchangers. In them, both fluids run through the same space alternately, so that a surface receives a heat of the hot fluid, to sequentially transmit it to the colder one, when contacting the same surface. Atmospheric phenomena. Heat wave is a prolonged period of excessively hot weather, which may be accompanied by high humidity, especially in oceanic climate countries. Cold wave is a weather phenomenon that is distinguished by a cooling of an air. Specifically, is used by the U.S. National Weather Service. A cold wave has a rapid fall in temperature within a 24 hours period, requires substantially increased protection to agriculture, industry, commerce, and social activities.
Now, I'm going to explain the station number 3 of physics, that is about electricity. It starts with electric charge. Matter is made of atoms, and atoms are made of elemental particles called electrons, protons, and neutrons. Electrons and protons have a property called electric charge. Then there are three types of ions. Neutrons have neutral charge, electrons have a negative charge, and protons have a positive charge. This leads us to fundamental principle of conservation of electric charge, that is say, if an object loses electrons, another object will gain those electrons. When a substance has a charge and starts having contact with other, we can find the law of charges. Like charges repel each other, unlike charges attract each other. Now I'm going to see how energy passes through an object to other. An object is charged by contact when touched by another charged object. An object is charged by induction when it is near a charged body. Coulomb's law establishes the magnitude of the electric force between 2 points charges is directly proportional to the product and inversely proportional to the square of their distance. An electric field exists in the space around the region of an electric charge that experiments an electric force. An electric field has magnitude and direction. Now we're going to see some concepts to electric circuits. The potential electric energy of a charge at point B compared to point A is equal to the work done against the electric forces needed to display the charge from A to B. The potential difference between point A and point B is the work necessary to display a unit of positive test charge from A to B. This is the work done divided by the positive charge unit. Electric current is defined as the amount of electrons that flow through a conductor. Electric resistance is the opposition that conductor offers to electric current flow. Now, some devices used to measure electric current are called ammeterers. The devices used to measure the potential difference of voltage are called voltmeter, and the devices used to measure the resistance is called ohmmeter. Now, for an electric circuit, a closed circuit in which there is a motion of charges from an element that pumps the charges through a conductor passes through a device that changes electric energy to another type of energy like kinetic, light, heat, etc. and then return to the system is called electric circuit. The first and the most simple form of electric circuit is made of a source, a resistance, and wires. The second form consists in a source with two or more resistors connected one after other. This is known as series circuit. The third form of a circuit with two or more resistors connected electric to a source, which is called parallel circuit. The fourth and the last form has two or more resistors connected in series, or more than two branches connected in parallel. This is also called mixed circuit. Now, for example, I'm going to try to explain the integrative activity stage train, that is a mixed circuit as a problem. So the first step is to redraw all the circuit until we get the circuits together, like in one resistance equivalent. So now that we have our resistance equivalent, we have to get the electric current that is going to help to get the voltage of each resistance. The electric current, we're going to get it with the voltage of all the circuit over the resistance equivalent. So when we have the electric current, we're going to multiply it with each resistance from 1, 2, 3, 4, 5, 6, and the end is going to be to our voltage of each resistance. The electric current is going to be the same for all, and the potential is going to be the multiplying of electric current with voltage. And that's it, we have our problem complete. Now, for electric circuits and electricity in real life, so we can see it at every moment. When you turn on a light, we're using an electric circuit in simple form that just have a switch, a resistor, and wires. Well, there also can be more complex circuits when you turn it on a television or a computer. But everything that is involved with electricity, it has electric current, resistance, voltage, and everything that is involved with electric circuit. And that is the main idea or the central for everything electric.
Sound sources. The sounds allow us to know better what is around us. The ear is the sense that allows us to hear and perceive the different types of sounds. Sound in physics is any phenomenon involving propagation in the form of elastic waves, whether audible or not, usually through a fluid or other elastic medium that is generating the vibration movement of a body. The humanly audible sounds consist of sound waves consisting of oscillations of air pressure, which are converted into mechanical waves in the human ear and perceived by the brain. The propagation of sound is similar in fluids, where the sound takes it from pressure fluctuations. In solid bodies, the propagation of sounds involves variations of tensional state of the medium. In a few words, sound travels through the air through waves, causing the eardrum of our ears to vibrate in order to be able to listen. For example, when we throw a stone in the sea or a river. The propagations of sounds involve transport of energy without transport of matter, in the form of mechanical waves propagating through solids, liquid, or gaseous matter. As the vibrations occur in the same direction in which the sound is propagated, it is a longitudinal wave. The sound is divided according to the pitch, either in treble or bass. Treble have a high frequency and propagate at high number of cycles per second. Bass has a low frequency and propagates at a few cycles per second. Are classified as strong or weak according to the intensity. In the strong, their waves have greater amplitude and the weak ones little amplitude. They are also classified according to their duration and according to their timbre. Sound propagation. The sound propagates from one place to another through a material medium such as air, water, or wood. In the void, the sound cannot be propagated because there is no natural environment. In the air, the sound travels at a speed of 340 meters per second. The propagations of sounds in fluids takes them from a pressure fluctuations. In solid bodies, the propagations of sounds implies variations of the tensional state of the medium. The propagations of sounds involves a transport of energy without transport of matter, in the form of mechanical waves that propagate through solid, liquid, or gaseous matter. As the vibration, the decibels measure the ratio of a given intensity to the intensity of the hearing threshold, so that this threshold takes the value of 0 decibels. Optical devices. They are instruments based on the properties of mirror, prisms, and lenses used by man to achieve the visions of objects very small or very far away in favorable conditions. An example may be the dark chamber, that is a closed box with a small hole in one of its walls for the entrance of light rays. Straight. These form in the wall facing the hole a real inverted image of any object placed on the outside in front of the hole. The size of the image grows with the distance between the hole and the wall, consisting of a frosted glass, paper of China, where the image is formed. By decreasing the diameter of the hole, the image gains its sharpness, while it loses in luminosity. Another may be the astronomical telescope. This apparatus used in the observation of the celestial bodies and consists of two converging lenses, a lens and an eyepiece. The objective provides a real and inverted image, and through the eyepiece the observer sees a virtual image of the same sense, inverted with respect to the object. The distance between the lens and the eyepiece must be equal to the sum of their respective focal distance. A last example would be the stereoscope, which is an optical instrument through which photographs of objects can be observed, but not as flat representations, but with solid appearance and depth. It is an instrument where two photographs of the same object are presented at the same time, one to each eye. The two photographs are taken from the slightly different angles and are observed through two lenses with separate and inclined lens to match and merge the two images into a three-dimensional. To remember what we have seen in class, we can solve the following exercise. The heart of a patient beats at 280 beats per minute. How can a doctor determine its frequency? The answer will be obtained using the formula of cycles between seconds or oscillations between seconds. That in this case, the heart that is being the process performing a pulsation of 280 per minute, which means that the 280 are the cycles. So the frequency will be the number of cycles, that is 280, between the time, that is 60 seconds. and the answer will be 4.66 Hz.